Numbers. What are numbers? Well, let's use apples to know what they are. You see, this is an apple, these are also apples, but what is the quantity? This much, but nobody understood that. The quantity of apples is 3. Did you get it? Of course you did. A number is a representation of a quantity. Now how you write numbers depends on the number system. The one humans are comfortable with is the decimal system, or 10 digits, probably because of 10 fingers present on one's hand. Machines, however, understand only the binary system, or 2 digits. But this isn't a video on number systems. You see, to calculate how many logs it would take to build a house, you need operators. In arithmetics, there are only 2 things you can do: decrease and increase. Succession is adding 1 to the number, and precession is the arch nemesis. This is the base of all math, or level 0. To increase by a certain quantity is to add, and the addition of numbers give a sum. To subtract is the opposite. The subtraction between 2 numbers is called difference. We could say addition and subtraction are repeated succession and predecession. This is level 1. Now if we repeatedly add the same number to itself, it is multiplication, and the multiplication of a bunch of numbers is called product. Now if you subtract the same number from a number and count the number of times you do it until the original number reaches 0, it is called division, and it's the arch nemesis of multiplication. This is level 2. The next level is exponentiation, and its arch nemesis is logarithm, and the next is tetration, and then pentation, and then, okay, maybe it's enough. You see, decreasing operations gives us goofy results, starting with subtraction. If you subtracting x from y and x is bigger than y, you get negative numbers, or numbers less than nothing. They represented by the minus sign. For your information, numbers more than 0 are represented by plus signs and are called, you guessed it, positive numbers. It's mostly used to represent debt. They both are collectively known as integers. To perform level 1 operations, just reverse the operation being used on it. For level 2 operations, if the 2 numbers have same signs, then the result is positive, and if they are different we get a negative number as the answer. Rest everything is the same. For third level, if the exponent is even, then the number is positive, if not, negative. Now I'm too bored to talk about tetration, so let's skip it. Now let's talk about division. Division can also be defined as separating a number into equal parts. When we divide 3 by 2 we get 3 over 2. Now this is called a fraction. Here the number is not whole, the numbers themselves are divided into parts. 3 over 2 is just 1/2 of a number. Numbers which aren't divided are known as whole numbers. With reference to division, some properties have been given to numbers. A number divisible by 2 is even, a number which isn't is odd. We literally call numbers indivisible by 2 weird. And most importantly, if a number cannot be divided by any number other than 1 and the number itself, it is known as a prime number. A perfect number is a number whose factors add up to a number twice the size of these original number. A factor is a whole number which can divide a specified number. For example, all even numbers have a factor of 2. A multiple is a number obtained by multiplying a specified number by a whole number. For example, all multiples of 2 are even numbers. The same is true for multiples of 2. Now there is an easy algorithm to divide any number. Before that, let's talk about decimals. If you divide 2 numbers and get a fraction, we represent it as a decimal. Now a decimal is an extension of the decimal system to include fractions. For example, 3 divided by 2 is 1.5. That point is known as decimal point. The number to the left represents the whole part and the decimal represents the extra fraction part. This is a really clever trick and enables us to do operations with less hassle, but sometimes numbers to the right keep repeating, like when you divide 1 by 3. Then we have no choice but use fractions for precise measurements. But we can represent it using this vinculum over here, so basically everything under this repeats. Another cool trick is if you divide this by 1 minus 1 with how many digits you have zeros. Okay, I got too distracted now to dividing. You see, we use this box over for division operations. Here we keep the number to be divided or the dividend, and here is the number that divides or the divisor. The whole part is kept here, and this is what remains to be divided. This can be easily written as a mixed fraction, a fraction with a whole part and a non-whole part less than 1. But it would be easier as a decimal. Step 1. start from the left and select the first digits to form a number. Keep on using more digits until you get a number that is less than the 10th multiple of the divisor but more than the divisor. Step 2, subtract the number by the multiple closest to it without exceeding. Step 3, write the multiple you used over here. Step 4, repeat using the subtracted number until you get a number less than the divisor. Step 5, divide the divisor by 10 and subtract the remaining part, if the number less than the divisor isn't 0, and keep on dividing by 10 every time you repeat. Now if the dividend is smaller than the divisor, use the 0th multiple of the divisor and divide the divisor by 10, until you get a number that is bigger than the subtracting number, and continue until 0. Now if you wanted to represent a part of a number, how would you do it? Well, there are two methods. Find two numbers which when divided give your part of number, or use the decimal system. You can use the fraction method and just divide to get the decimal, but there is another method. You see, if we divide 1 by 10 we get 0.1, if do it with 100, we get 0.01, and now we just multiply it with the suitable number. For example, to represent a half we divide 1 by 10, 0.1, and we multiply 5, because 5 is half of 10. We can do the same with 100, multiply 0.01 with 50 because it's half of 100. Let's get back to division for a quick bit. You see, if we stop when we get a number less than the divisor, the number is known as the remainder, and this part over here is called the quotient. Now if I divide the remainder with the divisor I get the non-whole part. If I write the quotient, the remainder, and the divisor like this, we get a mixed fraction. Now let's perform operations on fractions. In a fraction the dividend is known as numerator and the divisor is known as the denominator. For first-level operations we need to get the same denominator. If you multiply the numerator and the denominator by the same non-zero number, the value does not change. There are two operations that are related to factors. To find the number we must multiply the denominator and the numerator. We first find the lowest common multiple, or the LCM, of the denominators of the fractions to be added or subtracted, and then divide it by our denominator to get the number we must multiply. Basically we find the denominator of the end result. And after this step we have to simply add or subtract the numerators. You see, in math it is always necessary to simplify. We can simplify fractions as well. For example, 2 divided by 4 can also be written as 1 divided by 2 because they give the same result in the decimal form. This saves quite a lot of hassle. And how do we find the simplified form? Well, you see, the operations are similar to their arch nemesis. In multiplication, if we divide x by y we can write this as x into 1 over y. For addition it is x minus y is x plus negative or minus y. So if we divide both numbers by the same non-zero number we get the same value. Now what number to divide? We divide by the highest common factor, or the HCF, of the numerator and denominator. To find it we take the bigger number. Now sometimes the numerator can be bigger and this is called improper fraction. This is why I said the bigger number and not the denominator. Basically we find the closest multiple of the smaller number to the denominator without exceeding, but after subtraction we set that as the new divisor and the previous divisor becomes the dividend. We repeat this until we get 0 and the HCF is the last divisor. Now on to multiplication of fractions. It's pretty simple, we just multiply the numerators and the denominators. Fun fact, the product of the HCF and the LCM of two numbers is equal to product of the two numbers. Now exponentiation is just repeated multiplication, so do it for the fractions yourself. That's it for this video. PEMDAs or BODMAs, exponents, irrational numbers along with some cool operations you never knew are left. This will be covered in part 2.